Momentum is a vector equals to mass times velocity. Vector. So first for momentum, linear momentum, we use the letter P. I know you're thinking, why not L? Don't worry, L is for something else. So it's a vector, so it's the letter P with the hat over it. When you see that little arrow, that means it's a vector. So linear momentum, according to that definition, equal to mass. Mass doesn't have, it's not a vector, times the velocity. The velocity is a vector. So the direction of the linear momentum will be the same direction as the velocity. Now, if we look for the units for linear momentum, what is the unit for mass? What do we use? Isn't that kilogram? And what's the unit for velocity? It's meters per what? Second. So that's the unit for momentum. Kilogram, meter per second. So let's take this example. We have a jogger. Not sure anyone still jogs. We have cars now that will take us somewhere. The mass equals what? Let's say 72 kilogram. The jogger is running in this direction, the positive x direction, with the speed of 3.3 meters per second. So the question is, there we go, what is the jogger's linear momentum? Yep, the linear momentum of the jogger, it's a vector. It's equal to the mass times the velocity. If the jogger is running to the right, then the linear momentum will be which direction? To the right. It's the mass, which is 72, times 3.3. And where's my calculator here? $72 times 3.3, 238 kilogram meter per second. Let me take another example. We're talking about sports. Let's use hockey. Someone said, you like hockey more than baseball? Who was it? Hockey? Was it baseball? Yes, I like hockey. I like the Celtics, Bruins, Red Sox, all of them. A puck is roughly 170 grams. That's the mass of a hockey puck. So we got a hockey puck, usually they're black there. The mass equals 170 grams. And that means what? 0.170 kilogram divided by 1,000. If the puck has a momentum, the magnitude of the momentum, so I'm not giving you the directions. When you see the lines up and down, that's the magnitude. If the magnitude of the momentum of the puck is equal to 1.52 kilogram meter per second. Find the speed. Speed is not a vector. We're looking for the magnitude of the velocity. I couldn't really ask for the velocity because I don't know the direction of that vector. Again, the value or the magnitude linear momentum as vector equals mass times velocity. If I'm looking for the magnitude alone, I'll go 1.52. That's okay, I got it, thank you. Equals the mass, which is what? 0.170 times the speed. Do we know what the speed of the puck is? 1.52 divided by 0.17. It's 8.9 meters per second. I'll do one more example with linear momentum. Airplane. Commercial plane, these big planes. The speed of the plane, I'm not giving you the direction why that's why it's the speed. It's 55 meters per second, so a small plane. 55 meters per second. What's 55 times 2.24? 123 miles per hour. Has a linear momentum. The magnitude of that equals 40,000 kilogram meter per second. Can we find out what the mass of the aircraft? What's the mass equal to? So again, momentum equals mass times velocity. Momentum is what? 40,000. The mass is unknown. The velocity is 55. So we know the mass of the aircraft. 40,000 divided by 55. 727 kilogram. So if you are given two things, you can find the third one. Let's see what happens here. Let's take another example. What is those? What are they? Do I have one of those? We have a tennis ball here. And do I have one of those stress balls? I think I might have one somewhere here. Do I have a stress ball here? I don't have one here. But the stress ball is soft, squishy. What happens when you drop them? They don't bounce. What happens when you drop this? It bounces back up there. So the other one sticks to the ground. So let's look at both of these. We have two balls. So this is, or maybe it will say a stuffed animal. The kids have these stuffed animals. So this is a bear. There we go. I don't know, that's a bear.
Oh, that's a nice bear head.
Yep.
Pikachu.
It
does look like Pikachu.
You have the little black tips on.
There we go, good enough. It looks like, I don't know. And there's a ball here. They drop from the same height. When the bear hits the ground, stuck, it doesn't bounce.
You know that some of your drawings are dark?
Like my personality, dark.
Yeah.
Well, I can't draw anything. I always try to use bright color because I know I was told color represents your personality. That's why we're always the bright colors. But drawing, I can't. I don't have any talent. But you might be right. Who knows?
Yeah.
Today I might be. I don't know. Now, what happens to the ball when it hits the ground? Bounce back up there. Goes right up there, where this one just stuck to the ground. Let's assume the mass is the same for both of them. And we drop them with the same speed. So this one has a final speed of 0. Doesn't bounce. Where this one is going to move up with speed there. So is the speed going to be the same if it's bouncy? Not really, this because we lose some to friction. So let's call the speed going up, I don't know, V2. If it was frictionless, this will bounce back the same height. It will go on back and forth all day long. Nothing's frictionless. We can pretend it is. So let's look at the initial momentum, P initial here. Now, you want to define up as positive or down as positive. Up is negative, it's up to you. I can use to the right is positive and up is positive. It's really up to you. The initial momentum for the ball, for the bear here was what? The mass times the velocity. In which way the velocity? Was it up or down? So that's a negative V. What is the final momentum here? It's mass times the velocity. What is the velocity of the bear when it hits the ground? After it hits the ground? 0. So the change in linear momentum is equal to the final minus the initial. The final is what? 0 minus the initial, which is a minus. So the change, delta means change in math. So this always means change. And we call that delta. You'll see it a lot in science, the change. It's equal to what? Mass times velocity. Now let's look at that tennis ball here. What was my initial momentum for the tennis ball? It's the mass times the velocity, which is negative V. So initially both of these guys have the same momentum. Once the ball hits the ground, bounces back up. What's my final momentum? Mass times the velocity, which is V2. So what is the change in linear momentum for the tennis ball? It's the final minus the initial. What's the final? mv2 minus the initial, which is minus makes it a plus mv. So momentum, again, could be positive, could be negative. It depends on the direction you're moving. Could be 0. Let's take this example. This is in 1 dimension. What happens if you move in 2 dimension?
Wait.
Go ahead. Go ahead.
Okay. That's fine. Thank you.
No problem. Now we got, I don't know, some animals. I won't draw the animals here. I'll just say dog, cat. Well, dog and cats don't like each other, so how about duck? We're going to go to the pond, throw some bread in the We have a duck that's going this direction. We throw a piece of bread here. That's bread. Hard piece of bread. They can't really break it. All the duck sees it, they come running. We have another duck coming in this direction. That's duck 2. This is duck 1. Oh, you want a goose?
Swan.
Here we go. Valentina, she wants a goose.
And then the swan swoops in and takes it all.
So each duck here has a mass. We'll say the duck for each one has a mass of 4 kilograms. Those are good sized ducks. Enough to feed the whole family. Do people eat duck?
Yeah.
You do? Oh yeah, Peking duck. It used to be a Chinese restaurant. They used to have that duck. But maybe not the ones in the pond here. Maybe you can't touch them.
So the goose has got to be like 6 or 7 kilograms.
Well, let's make it a fat goose since all these are fat animals. How about 9 kilograms?
Oh, wait.
They're big actually. And this duck is moving in this direction with a speed of 1.1 meters per second. This is moving that direction of 1.1 meter per second. And the goose is going toward the bread with a speed of 1.3. That's why she's fat, 9 kilograms. She wants to eat that food. So the question, what is the magnitude? Find the magnitude that's the value. I don't care about the direction. We'll give you the direction even. Let's go to direction. And direction. Makes it more fun. Of the total momentum. Of the 3 birds, I don't know. We get the idea. I think you know what we're talking about. But if you're not sure. That's what the question is. Can we find the momentum? Remember, momentum is a vector. I'm going to use this as positive. I'm going to use this as positive. Okay? So let's look at each one. Then linear momentum by duck 1, D1. That's duck 1. That's this one. Is that going which way? To the right? Is that positive or negative? Positive. The mass times the velocity, which is what? The mass is 4. The velocity is 1.1. That's 4.4 kilogram meters per second. In which direction? In the x direction. The linear momentum for duck 2. Duck 2 is coming down this way. Is that positive or negative? Negative. Mass times velocity. Which direction? In the y direction. And let's look at the goose. That's going the positive y direction. The mass is 9. The velocity is what? 1.3. 9 times 1.3. 11.7. So now we're going to find the equivalent of them. The total number. What is P total here? That's what the question. which is equal the linear momentum of duck 1 plus linear momentum of duck 2 plus the linear momentum of the goose. Duck 1 is what? 4.4 in the x direction. Duck 2 is what? Negative 4.4 in the y direction. And the goose, which is what? 11.7 in the y direction. So what do we have? We have 4.4 in the x direction, and in the y direction should be what? What's 11.7 minus 4.4? We're adding vectors. The x is together, the y is together. 7.3 in the y direction. So now you really know the x and y component. That's what you know. Can we find what the magnitude of that? Because we're asking for the magnitude and the direction. How do you find the magnitude of this vector? Is going to be what? The square root of the x value squared, that's vector addition, plus y value squared. .5 kilogram meter per second. Theta, notice you're in the first quadrant. There is no adding 180. It's the inverse tangent of the y value, which is 7.3, divided by the x value. The inverse tangent of 7.3 divided by 4.4. 59 degrees. Remember, I said linear momentum is a vector, should have a magnitude and a direction. This is the value of it, that's the direction. So the three of them, the three ducks, the two ducks and the goose there, will have a combined linear momentum to equal to that number. So that's the first topic, linear momentum.